previous lessons, we finished with the computer hardware. Now, when we look at computer software, when we talk about computer software, we're talking about programs, okay? We are talking about programs. Computer software, we're talking about programs. Now, these programs are the ones we use on the computer. And how do we come to use this program? These programs are written, they are programmed, they are designed by people who use computers, okay? Programmers, they are the ones who come up with these programs. And these programs are intangible. What do I mean when I say they are intangible? It means the programs cannot be touched by a human being. We cannot touch them. However, we can see them and we can also hear some of them, okay? Something soft copy, okay? Immediately, okay, someone is saying, where will we get the notes? I'm going to share with you the notes immediately after this lesson, okay? On your different WhatsApp groups. Please, you remind me. At the end of the lesson, you will receive these notes. Just like we received the notes for hardware before we started them, we are also going to receive these notes so that we can move in. Now, keep your questions for now. We are still moving. Joshua, I know you are curious, but we are reaching there. We are moving. We are in software. Ask the questions accordingly. Where we are moving is still far. We shall even see what programming is in the future. Okay, let's just keep calm. Let's introduce software and then we move. You ask the questions where it's necessary, please. Right now, let us focus on understanding what software is. So when we look at our phones, in our phones, we have several applications, many, even Zoom, the Zoom we are using, it is a software application, okay? It is a software because they are just instructions which the computer is following to make us understand how it works or to make us use it, okay? Now, other applications are on our PCs. We have Adobe Photoshop. We have the Windows operating system itself is a software. So we have several softwares we use on our computers. And these softwares are simply instructions. And these instructions are electronic instructions. Or someone can call them commands. Or someone can say they're just programs which do what? These programs or these instructions tell the computer how to perform its tasks. It tells the computer what it should do. Okay, so if you're asked in a paper, which is possible, they can ask you what computer software is. All you have to say is you have to mention to us that these are electronic instructions or commands or programs which tell the computer how to perform its work or how to do its work or how to perform tasks. Okay, now they are intangible, like I told you. They are intangible components of the computer system. And yet we say the hardware are tangible because we can touch them. And from that, we can understand what tangible means and what intangible means. Our software are intangible. We can't touch them. Now, that brings us to what we call a program. Okay, a program. A program, members, when we talk about a program, we talk about a complete sequence of instructions. Now, these softwares are actually programs, okay? These softwares are programs, or a software can comprise of very many programs put together. But a single program is simply a complete sequence of instructions, for data processing to be performed by computer. So for the computer to perform its work, it must follow certain instructions which are in a program. So when we have a complete sequence of these instructions put together, it forms what we call a program. That's why people who program, they tell you, I'm going to write a program, okay? I am going to write a program. So this program is not the program we normally have in our lives, on our daily lives activities, saying, today my program is as follows. I will do this, do this, do this. This is not the program we're talking about. This is the program we're talking about in terms of instructions, which are supposed to enhance data processing in a computer, okay? Then we have the subdivisions of what we call the subdivisions of software. Software is subdivided into two main categories. That is application software and system software. Now we are going to go into depth to understand application software and the system software. But before that, let's look at user interfaces. Now, members, when you're interacting with a computer, when you're interacting with it, there's a way the computer displays information to you. Not so. There's a way the computer displays information to you. There's a way it tells you to touch here in order to do this. The way it interacts with you, or the way you interact with the computer is on an interface. Is on an interface called user interface. The user interface is simply the way in which the computer presents itself to the user. Then the way the user will also communicate and interact with the computer in terms of giving the commands, okay? For example, you want to open WhatsApp. You want to open WhatsApp, all you have to do is open your phone and then look for where WhatsApp is, and you tap on it to open it. Not so. You tap on it to open it. That is how you have entered the command to open WhatsApp, okay? So we have two types of user interfaces. We have what we call command line interface. We have another one called graphical user interface. Now, these names, when you look at them, the names are actually, they're explaining themselves within themselves. Command line, it means we're writing lines of commands on this interface. Graphical user interface, we have graphics on the interface. You see, if you look at these words, they actually try to define themselves. Now, we're going to start by looking at what we call command line interface, which is the first type of interface. Now, command line interface, members, here there are no graphics. You don't have images, you don't have pictures, you don't have icons to click. You simply have a black screen on which you type commands. You want to open WhatsApp, you have to write words, you have to write a command to open WhatsApp. You want to open something, you have to write a command. Now, in our Windows operating systems and the Linux operating systems, we have what we call the terminal. In Windows operating systems, the terminal is what we call the CMD, or the command prompt. It is the black screen onto which you can type your, okay, onto which you can type your programs, your commands. I'm going to show you. Now to open your CMD, mostly you have to go through the Windows start button, and then you look for CMD. Then there's also another way you can go through the command window. Okay, now I'm just going to show you. I am going to show you how to open. I'm going to show you how to open CMD on your computers. Can you see? Can you see what I've just shared? Are you able to see the screen? Are you able to see the screen?
Yes.
Yes, sir.
Yes.
Okay.
Yes.
I've just opened. Have you seen this small window here?
Yes.
Yes, I opened that window by pressing a command. Yeah, someone is asking a window. What is a window? Joshua, a window, when I talk about a window, whatever I've displayed. Now, when you look at this, I've opened. Joshua, this is a window, okay? It is a window. Then even the whole of your screen display is a window. Anything you open, it opens in a window, okay? It's not the windows we have on our houses. But now I want to show you how I can open my CMD. First, I can open it by first going to the start menu and then looking for the word CMD. It is there. You open it by clicking on it. Okay, are you able to see the black screen, which I've just opened?
No.
No.
No, teacher.
Okay.
No.
Sir, what's the CMD?
Wait, let me come
Central
there.
Command Center.
What's that?
CMD for Central Command Center.
Okay. Wait, are you seeing the black screen I've just shared?
Yes.
Okay. I want to share all.
Yes, teacher.
Okay. Okay, I want to start it from scratch, so that we can see how I am even going there. I want us to go and see how I opened it. I want you to understand. I want you to understand how these things work. Okay, I want you to understand how these things work, how we can open it, and so on and so on. Now, okay, I've just stopped sharing. Now I'm going to share afresh. I'm going to share afresh. Okay. Are you all able to see my screen now?
Yes.
Yes.
Yes, sir.
Exactly.
Yes.
Now,
What's the CMD?
okay. Now, okay, I understand you have questions. I'm going to answer your questions by the end of today. Now, the CMD, like I told you, when we have commands to answer, when we have commands to write into the computer, we write them on a black screen. That black screen is what we call the command line, okay? And in Windows operating system, this is Windows operating system. Most of you know how Windows operating system looks like, okay? In Windows operating system, we have a command line interface called the CMD. CMD stands for command prompt. CMD is actually a short form for command. In Windows, we call it command prompt or CMD just in short. Now, how do I open CMD? I am going to click on the Windows logo button, the start button. Are you all able to see what I've clicked?
Yes.
My screen has gone dark.
Now, if you can see this, to open CMD, you simply search for it from here. You type here CMD. It is that one up there, command prompt. It is the command line interface I'm talking about. You can see it is a black screen and it is ready to receive commands. It is ready to receive what? Commands from its user. Kyle Onua, you have a question?
So what about the method of using Windows R?
Don't worry, I'm coming there. There are very many ways of opening this, okay? So this is what we call a command line. Now in this command line, you can enter different commands. For example, a command ls cd, you can actually say, so many commands you can enter here, okay? You can open so many commands, okay? Now, these are just commands. Whatever I want, I have to type a command, okay? So this is what I call the command line interface. It is not the same as this other interface, which we are going to look at, called the graphical interface, okay? I can even change the color just by typing a command, okay? I can change the color, okay? So I'm just dealing with commands and commands. You have to know these commands. With this, you have to understand which command to write. Okay, this is what we call the command line interface. The user must only use commands to type. Okay, this is the command line interface. Now, when we look at the graphical interface, going back to our presentation, when we look at the if you want to ask a question, you have to put up your hand. I will always tell you to unmute, and then you can talk, okay? Otherwise, we have to be, someone is asking what is a command. Those instructions you're writing is a command. When your mom tells you, go and fetch me that water, that is a command, okay? Your mom is telling you to do something. So by writing things on the black screen, we are actually giving a command to the computer to do something. So those commands, you'll understand them in your future. Adrian, I hope you're clear. Now, that is the command line interface. Now, when we look at the advantages of the command line interface, before we look at the graphical user interface, it is very fast in executing commands, okay? that the interface can execute commands because you are giving commands direct using the keyboard. You don't go through channels of first clicking on the folder. And then, for example, if you want to open your games, you first click on Windows and then you search for Windows and then you go and look for the game. There you're wasting time. With this, you write a command which will open the game at once. Okay. These commands are very, very fast in execution. Okay, then it takes up little memory and normally does not require a very fast processor. We looked at processing devices in our previous lesson. These processing devices differ in speed. We looked at the speeds, okay? Now, these commands, the command line interface doesn't need a lot of speed because here, first of all, the commands are fast. It takes up little memory, okay? The commands you are simply using words and each character is just 1 bit, 1 byte, okay? Now, the other advantage is many commands can be grouped together as a batch. You can actually perform several commands at once. You can say open this, after open this, close this, and after closing this, do this, just in one command. And when you press enter, it is going to process all those commands. Those are the advantages of command line interface. Of course, everything has its own disadvantages, and we are looking at the disadvantages of command line interface now. The very common one is a command language has to be learned and memorized. That is to say, it is not user-friendly. If you want to use the command line interface, members, you must know the codes, you must know the commands, you must memorize them. That is where the disadvantage comes in. But it is very unfortunate that we have several commands we can use in the command line interface. Okay, so that is a very big disadvantage. Now, I'm sure some of you are wondering, how is he even typing those commands? How is he doing that? How is he doing that? Okay, now I memorized them, meaning if you also want to use the commands, you have to memorize these commands. Okay, now if I go back to the command line interface again, someone asked how I can open it using the Windows button plus R. Now, for the Windows button plus R, it is a command. It's called a run window. The run window is also a way of opening other applications. But in this case, our interest is to open the command prompt using the run window. So the run window, you press the Windows logo button plus letter R on your screen, on your keyboard, sorry. It's going to open for you this small window you're seeing here. Now, when you see this small window, it has somewhere you can type. This is where, okay, someone is saying he can't see my screen. Others are seeing the screen, I think. Are the rest of you seeing the screen? You can send a yes on the chat section. Are others seeing my screen? Yes, others are seeing. That means everyone is almost seeing. Okay, now, this run window is where we type the commands. You can open anything from here. I used it to, or I can use it to open Notepad just by typing Notepad there. It means you must also know the commands to type there. Now, in this case, our interest is to open the command line interface of Windows. You simply type the word CMD, as simple as that, and you click on OK, or you press enter. It opens for you the window, as simple as that. That is how we access the command line on our Windows operating systems. Okay. All right. I hope I've helped the person who was asking how to open it using the run window. All right. Now let's continue. So we have already looked at the disadvantage of a command line interface. Now, let's look at what we call the graphical user interface, the one we are all using. Even on our phones, we are using graphical user interfaces. How are these graphical user interfaces different from the command line interface? Now, for the graphical user interface, members, it provides us with the menus, with the visual images such as icons, buttons, and other graphical objects to be used or to issue the commands to the computer. Okay. For example, when I go back to my desktop here, hoping that you can all see it. When I go back to my desktop, you will actually notice that I have icons on which I can select. All I have to do is go to an icon, I click on it to open it. So this is what we call graphical. Everything is graphical. You don't issue commands. This is what we call the graphical user interfaces. We have menus, okay? Menus are here. These are menus. We have menus. We have many other things which are just graphical. All you have to do is go there and click. Go and click on it, okay? Now, members, let's look at the advantages of the graphical user interface. Now, the graphical user interface is user-friendly. Why? All you have to do is click. To open something, you go and click. To open something, you go and click. It's very, very simple. User-friendly because it is easy to learn even to work with. Some of you were not taught how to even use your phones. You learned on your own. That is how easy the graphical user interface is. Then there is no need to type and memorize any command language. You don't have to memorize. It was until now that some of you even knew that we can actually write commands in a CMD. Here you don't need, because you have been used to opening your files and your programs by simply clicking on the different icons, okay? Then the interface is similar for any application. How is this possible? When you open Microsoft Office Word on your computer, you will notice that it is almost the same interface you see when you open Excel, because you close it on the same, there's that cross in the corner where you close them from. All these applications are related. So you'll see that the applications, the graphical user interface is similar for different devices, okay? For any application, they look similar. Even the operating systems, Windows operating system is almost similar to Linux operating systems, okay? Some of you are going to ask about Linux, but don't worry, it's just another type of operating system. We shall look at operating systems to come, with the time to come. Now, disadvantages. The disadvantage is it requires more memory and faster processor. Your processor should be fast. Your memory should also be more. It should, because you need to store these graphical applications onto the computer. Each graphical application can be about 1 GB or something, okay? It needs memory. Here you're dealing with the graphics. If you're dealing with graphics, the computer needs to process these graphics. Now, in order to process the graphics in a very, very secure way, it must mean that the computer should be having a fast processor, because the processor has to process graphics. Graphics, we are dealing with a lot of things. Displaying color, displaying the image, the shapes, and so on. A lot of things involved. So the processor must be fast in processing these graphics. That is a disadvantage. Meaning weak processors cannot support, and may support, but the functionality may be very, very poor. The other disadvantage is it occupies more disk space to hold all the files for the different functions, because each program comes with its files, and each file occupies space. Now, if the files are occupying memory, it means for a program to run, there should be several files. When these files are put together, they occupy memory. So it occupies more disk space to hold all the files compared to the command line interface, okay? Now, let's look at the other thing is it is also difficult to automate functions for expert users, by the way. Now, some people are so expert that graphical user interface is even hard for them to use. They are used to the command line interface. So the disadvantage for them with the graphical user interface is that it can be difficult to automate functions for expert users, okay? Now, let us look at system software. Remember, we said software can be categorized into two: system software and application software. Now we are going to start by looking at what we call system software. Members, you remember when we started, we said computers work as a system. How do we say they work as a system? It is because different parts of the computer are connected together so that they can perform the task the computer is supposed to perform. Now, when we talk about the system software, we're talking about that software which enables these computers to work as a system. Okay, the programs which contribute to the control and the performance of the computer system is what we call the computer system software. Someone, I think, Ayebale, you have a question to ask. I'm just going to ask you to unmute, and then you can ask your question. I see on the chat section, you want to ask a question. Ayebale Tukunda, please ask. At the beginning of the lesson, I told you I will send you the notes. I will send you the notes. I will send you the notes after this lesson. Okay? I told you I'll send you the notes after the lesson. So simply wait patiently for the notes, okay? Okay. So we are still looking at the types of the system software. Now, I told you the system software contribute to the control and performance of the computer system. And we say the computer system is a collection of different computer components working together. They are able to work together because of what we call the system software. Without the system software, these computers cannot do their work, okay? How the devices interact, how the system is going to start, everything there is performed by the system software. Different programs that tell them how to perform their work. Now, there are types of this system software. We have 3 main types of the system software. The number one and the most important is what we call the operating system. The operating system is the mother of all of these. Why? Without it, we cannot even use the computer. We are using the computer now because our operating systems are running. I am running Windows operating system, Windows 10. You people who are using the phones for accessing the lesson, you are using Android operating system. Different operating systems are running in order for us to use these computers. They are important because without the operating system, the computers cannot be used. How you are using the screen is because the operating system allows you to use the screen the way it is. How you are able to use the mouse with the computer is because of the operating system. It is the main type of system software we have to look at. We're going to look at it. The other type is service or utility programs. These are the ones which enable the computer to work efficiently. We shall also look at them. Then we have programming languages. Programming languages, someone was asking what programming is. You will also understand what a programming language is as we move on. Now, let us start by looking at what we call the operating system. Now, the operating system is the master control program. I told you.
Last page.
Excuse me? Someone is asking a question.
Could you please put back on your last page, please?
What do you want to
There's
say?
something. There's something that's wanting to note down.
Okay. The types of, you mean this page?
Yes, yes, sir.
Okay. I'm just giving you 1 minute to finish whatever you're doing.
Excuse me, teacher.
Yes, please.
If the operating system goes off, can you put it back?
Yes. Whenever you're starting your phone, if your phone has been off, when you start your phone, it is the operating system starting, Android operating system. When your computer is off and you switch it on, it is the operating system starting. You understand? Is it okay? So the operating system is the one which actually makes us use the computers in the ways we are using them. Without them, we cannot use the computers. Now, someone is asking, are we going to learn HTML, Java, JavaScript, Python, CSS, Swift, and so on? Roman, some of those things, if we continue moving on together, we shall learn them. In the future, probably in senior 3, okay? We shall learn them, don't worry, you will understand them. It is possible that I might even be the one teaching them to you, or Mr. Mukulu or Mr. Dampa. Any of us will be teaching you those things. Those are things you, as a student, are supposed to learn, because in your practicals, you'll be told, you'll be given exercises on web design and so on. Okay, let's move on. Now, looking at the operating system. Yes, I understand. Someone is saying we are still in senior 2. Yes, you are moving there bit by bit. Now, let's look at the operating system. Now, I said the operating system is the master control program. The master system is the master control program in a way that it manages and supports the operations of the computer system. Okay? It manages and controls the operation of the computer system. Now, when you start your computer, when it is off, if your computer is off and you start it by pressing the button on it, the power button on the computer is going to load the operating system first, because without the operating system, we cannot even start the computer. Okay, we cannot use the computer without the operating system. So the computer will first load the operating system. Windows will load, your Android phones will load. Then after them loading, you'll be able to see your applications. Okay, it is the one that manages. Now, if you wanted to take a pic, when you tap on your camera on your phone, it is the operating system doing its work at the background. It does its work by doing what? It transfers the instructions from this camera program to the computer to be able to use the camera behind. So it connects your application on the screen to the camera behind your phone. Okay, to the camera behind your phone. So that, are there other people who are trying to join and they can't join? Because this is supposed to be unlimited. It's supposed to be unlimited. Okay, I think, yeah, we are good. We are okay. So that is the operating system. Now we are going to know that we already talked about the Windows operating system. I've talked about the Android. These are examples of operating systems. We even have Windows XP, which some of you are still using. We have Windows 7. We have what we call Linux operating systems. We have Macintosh, the ones we find in MacBooks and the iPhones. We have iOS, okay? iOS operating systems, and so on and so on. There are several examples of operating systems. Now, we are going to categorize, we are going to classify these operating systems. The operating systems can be classified into Drake, mind your language, please. Drake, I'm going to remove you from this class. We don't use such language in this class. So Drake, you're not attending our lesson today. I'm going to remove you because of the words you're using on the chat section. We don't use such words here. Okay? Drake, we don't use such words. I'm chasing you out of my class. So, because you've used a bad word, we don't use those words in our class. Okay? So Drake is no longer in our class because of the language he's using. Because of the language he's using. So I've removed the Drake from our class. Now, someone is asking a question in the chat section. Teacher, when your phone starts freezing, is it an error in the operating system? When the phone starts freezing, several problems can lead to the freezing of it, okay? The problem, it's not the problem with the operating system. It could even be because of viruses. There are several problems. It could be even because your memory is full, okay? Now, okay, let's classify these operating systems. We classify operating systems according to the way they perform their work. How operating systems perform their work. We have what we call real-time operating systems. We call them real-time operating systems because something real-time is present, current, online, okay? Something real-time. We're dealing with it in the right, at this exact moment, okay? It is, this type of operating system is a multitasking operating system that aims at executing real-time applications. These real-time applications may include WhatsApp, Facebook, because on Facebook you can see who is online. On WhatsApp you can see who is online. So these are examples of real-time operating systems. So such operating systems that manage these applications which are real-time are called real-time operating systems. We have distributed operating systems. Now, before we look at distributed operating systems, let's understand what distributed systems are. A distributed system is a collection of independent, I repeat, independent computers working together. Okay, independent. These computers are independent. Each computer is independent in performing its tasks, but they are working together to perform a common goal. Now, that is a distributed system, meaning a distributed operating system is an operating system that manages a group of those independent computers, and it makes it appear as if the computers are a single computer working. Okay. Now, embedded systems. In embedded systems, members, when we talk about embedded systems, we're talking about systems which have their operating systems or their programs embedded, meaning they have been put in them, inside them, embedded within them. Okay, they have been put within them. And something embedded is, for example, your eyes are embedded on your eye socket. Okay, that is what I mean by embedding. Now, embedded systems are those systems which have their operating systems embedded, they are within. They are not computers as per se, but their operating system, they run on, for example, your microwaves at homes, your washing machines, the big photocopiers which have certain screens, those ones run on what we call embedded operating systems. Okay. Now, these operating systems, they are very small in size. Okay, they are small in size. Look at it, like without the program, the computer, the machine can't work. When you go onto your microwave, there's a small screen which can enable you to even adjust the temperature of how you want the food to be. That screen, whatever you're seeing there, is managed by an operating system called an embedded system. Okay. Now, let's look at what you call single user operating systems. For example, the DOS. Now, remember, the DOS stands for disk operating system. Remember when I told you that whenever you're attending my lesson, you have to be keeping a small book where you take notes. You take short notes, because some of these things I'm saying are not actually in the notes you're going to receive. So the word DOS, the acronym DOS stands for disk operating system. It was one of the very first operating systems, but it only allows one user to use them. That's why we call it a single user operating system. So single user operating systems are those which only allow one user to run one program at a time. So when you look at your Windows operating systems, you'll see that on your Windows operating system, you can actually have two users running at the same time. Okay, that will take us to what we call multi-user operating systems. Unix is one of the examples. Windows is an example also. Here, one or more users can run a program on the same computer at the same time or at different times. Okay, those are what we call multi-user. Multi means many user operating. Many users can use it at the same time. Then we have what we call multitasking operating systems. Multitasking, a task is something you're doing. Right now, your task is to do what? Is to sit and attend the lessons. But because we can multitask, you can actually sit and attend this lesson while sipping your cup of coffee. So you're multitasking. So when we talk about multitasking operating systems, we're talking about those operating systems that can allow you to run one or more applications at the same time. For example, I might be typing my work on Windows of my Microsoft Office Word while listening to music. Okay, so the application that is playing music is running at the same time the Microsoft Office Word is running. That is what we call multitasking. So examples of these operating systems include Windows. Windows allows you to do that. Linux allows you to do that. Even the Android we are using allows you to do that. iPhones, the iOS allows you to do that. Mac OS allows you to do that, and so on and so on. Several other operating systems allow you to multitask. Then we have what we call multiprocessing operating systems. Multiprocessing operating systems. Now, multiprocessing operating systems members are the ones that can support two or more central processing units. Multiprocessing, it means there are two processors in this computer which are performing at the same time. You have a computer which has two processors. two processors, but they are all running at the same time. These operating systems are called, the operating systems which can run on these machines are called multiprocessing operating systems. Yes, Francis, I see you've raised your hand. Please unmute and ask your question. Francis, unmute and ask your question.
Excuse me, sir. If a computer is running with with more than one processor, isn't the computer generally faster when it comes to opening applications and its general speed when using it?
Yes, exactly. You're very right. The computer is very fast compared to those that are having one processor. Yes, you're right. When there are two processors in your computer is faster than the other computers which are only having one processor. Even the speed of execution, the speed of executing programs is faster than other computers. Okay. Yeah, you're right. What you asked is completely right. All right, let's continue. Let's look at what we call the popular operating systems, okay? The different types of operating systems. Now, when you look at this diagram, the image here, these are images of how the operating systems actually are represented. They have their own icons. We have Mac OS here. We have Unix here. Unix, the Linux and so on fall under Unix. We have DOS, the disk operating system, the very first one I told you, which is single user. We have Windows 7. We have the functions of the operating system. We have been talking about operating systems. Operating systems. What are the functions of the operating system? What does the operating system actually do? Number one, the operating system provides an interface between the user and the computer. So this graphical user interface you're seeing in your phones, on your computers, it is actually provided for you by the operating system. Without the operating system, you can't even use these computers and your phones. These devices cannot be used without the operating system. Number two, it manages the flow of information in the computer. The flow of information in which sense? If I click on something, that click is a command. It is a set of instructions I've sent to the computer. Even when I'm typing, this computer, the operating system, is the one that is responsible for communication between the keyboard and the CPU. Okay, the CPU has to process everything. So it is the one that manages the flow of information on the computer. Then it keeps record of the saved files. We call this file management. It is responsible for file management. The saved files, you can easily find them because the operating system allows you to do that. It also establishes relationships between hardware and software. Now, you can't use the keyboard without an operating system because the operating system is the one that establishes that relationship between the hardware and the software. For example, you have opened your software, Microsoft Office Word, and then you're typing work using the keyboard. In order for you to see what you're typing on your Office Word application or software, it is because the operating system has allowed you to do so. It establishes that relationship, okay? And then it also controls the running of other programs. For example, right now, we're running Zoom and it is timing us. That timing is part of the operating system. They're making use of the operating system to ensure that it times us correctly. It is the one that controls the use of peripherals. What are these peripherals? Those are the devices we attach. Those are the devices we attach to the computer while we're using them. For example, the keyboards in our computer labs, the mice we are using, those are computer peripherals. Even when we add the speakers to our computers, when we connect them, it is the work of the operating system. It's the work of the operating system to perform that, okay? All right. Then we also have, it organizes the memory management. When you save your work on your computers, on your phones, it is the work of the operating system to store them somewhere. It is the operating system that directs this work to be stored somewhere in the memory. Then it also helps in the booting process of a computer. Remember, I told you the operating system is the main system software, because it is the one without we can't use the devices, okay? So It is the one in charge. Kubunga, if you're not careful, I'm going to remove you from our class. Please make sure you remove what you've written on our screen. Remove what you've written on it. Thank you. Be careful, because I've removed certain students from the class just because of their behavior. Okay. So, someone is asking a good question. What is booting? By name Mugisha, that's a very good question. Booting is the process of starting the computer, as simple as that. When you start your computer, you're booting it. Okay. You're booting the computer. That is booting. As simple as that. Then it also helps in file management. Yes, someone is saying there's warm booting and cold booting. There's warm booting and cold booting. There's also rebooting and so on. Cold booting, you are booting a computer which has initially been off. Warm booting, you are restarting actually. When you restart a computer which has been on, it's called warm booting. Okay. Let's continue. It also helps in file management. Yes, it helps in file management. Now let's look at what we call programming languages. Here, I'm sure most of you are interested, because people who have that passion for computers, they look at themselves mostly as programmers in the future. Now, today we must understand what programming languages are. Exactly. Someone is saying, can I conclude that saying no operating system, no computer? Okay, not necessarily, but it is also partly true, because if you have a computer without an operating system, you won't use it. So yeah, it makes sense. No operating system, no using computer. You can't use it without the operating system. Unless you install an operating system on the computer, that is when you'll be able to use it. That is very, very okay. Okay, yeah. Kayemba, what you have just suggested is true. Yes, if you don't have an operating system, you won't use the computer. All right, now let's look at programming language. In layman's language, a language is a media of communication, not so. It's a media of communication between human beings or computer. Okay. Now, right now I'm communicating to you. I'm communicating to you through a machine, through a computer. Okay. The computer is communicating to you through displaying. Okay. It's communicating to you through displaying. Okay. So we interact among each other. We also interact with these computers. That means there has to be a way we communicate. Okay. When you want to read your notes, the computer has to open for you. You have to open, and the computer has to respond to you opening Microsoft Office Word or your Word document, and you read. Okay. So there has to be a communication, that is, and we use what we call a language to communicate. Right now, I'm using English to communicate to you. With the computer communicates to you using what we call a programming language. Okay. Now, let's understand what a program is. A program, we already defined it, logically arranged set or a list of instructions that direct the computer on what to do. Or you can simply say, it is a complete sequence of instructions which tell the computer what to do. Okay? It tells the computer what to do. Now, programming. When we talk about programming is actually a process. It is something we are doing. It is a multi-step process for creating computer instructions. So when you get your computer, you sit down and you start writing instructions for the computer to interpret. You are programming, okay? Then we also have what we call programming languages. Now, the programming language is the software program used by a programmer to write the computer software instructions. Okay, the language we use, the software program. Those are the programming are the programs we use as programmers to write the computer software instructions. Okay, they are called programming languages. Then the person who is writing this program is the person who is programming is the programmer. Okay, so those are the introductory definitions we can give there. Okay. I hope you are all paying attention. I know most of you are typing in the chat section, but please pay attention. Now, let's look at the programming tools. When we are programming, we make use of certain tools, okay? These tools help us to program efficiently. They make us come with programs that run very, very smoothly. Without them, we can't actually identify where the problem is. We can't know how to solve the problems. We can't do anything, okay? These tools are the ones we use. The first tool you have to understand is what we call a debugger. First of all, you have to understand what a bug is, okay? A bug is an error. When you are writing a program and your computer program has an error, let's pay attention, please. I'm seeing in the chat section, you're doing your own things. You're doing your own things. You'll share these later on, okay? The languages and so on and so on. You'll discuss them later on. For now, let us pay attention and follow, okay? All right, so a bug is an error in a computer program. When you write your program and somewhere as the program is executing, there's an error. That error is what we call a bug. And then when you find a bug normally, if you find an error, of course, whenever there's always an error, we try to remove the error, not so. We remove the error. When we remove the error, we call that process of removing or rectifying that error debugging. So a bug is an error. Process of removing that error is called debugging. And then the programs which help us to remove these errors are called debuggers. Okay, they are called debuggers. Then we also have what we call linkers. Okay, linkers are the ones that enable calculation of any function in the program. Okay, for example, if you're writing a program and somehow you have not gotten the logic you want to put it there, you can use a linker to help you understand the logic there. Then we also have editors. Without editors, we have nowhere to write these programs. So these programs have to be written in an environment which we call editors. These editors are so many. Without them, we can't write the programs. So you'll find editors like Dev C++ for writing programs concerning C and C++. We have what we call, there's also one for writing Python. There's so many of them. We have Visual Studio Code even. We have many of them. They are called the editors. They facilitate the creation, the editing, and also the formatting of these text files we are creating, okay? And then let's look at the categories of programming languages. Now we are going to stop here. I'll just introduce the categories. Let me see how long we have. Okay. I think we have about 30 minutes or 20. Okay, we are going to stop on the categories and then we shall join in for the next lesson next week. So the categories of programming languages. Programming languages are categorized. And someone is saying, teacher, what of Python programming? What are you asking about Python programming? Good luck. Good luck, Jonathan. What are you asking about Python programming? Anyway, categories of program. We categorize programming languages according to the days or the years they were invented. Low-level programming languages are the very first ones they used, the computers we used those days. The very first programming languages used are called the low-level programming languages. And the examples of these programming languages are machine code and assembly language. So there are two, machine code and assembly. We are going to understand this, don't worry. And then we have what we call high-level languages. High-level languages are examples include the fourth generation and the fifth generation, even the third generation are examples of high-level languages, okay? So we're going to understand this one by one. Now, I'm going to explain this and then up to here, and then we stop. And then we shall continue from there next week. Now, low-level languages, like I told you, the low-level languages members are the ones we first had, the first generation, the very first one. Now, we gave two examples here. We talked about machine language and assembly language. We are going to also look at them. But before that, we have to understand that here in machine languages, in low-level languages, looking at the machine language makes use of the zeros and ones. Yeah, the computer is at its basic level of understanding, okay? Here, the machine is the computer. The computer is at its level, at its basic level of understanding. The basic level of understanding is 1 and 0. That's why when someone asks you, what language does the computer speak? You don't waste time. Tell the person the computer speaks the language of zeros and ones, okay? So here the computer uses digits, binary digits, 1 and 0. What are the characteristics of machine codes? They can be used directly by the computer without interpretation because the computer understands zeros and ones. If you feed in a computer program or a program which is written in zeros and ones, the computer doesn't have to translate it. It doesn't have to interpret it. It simply uses the program directly because it is written in the language it understands, which is 0 and 1. Then they are machine or computer dependent, meaning it is only computers that can understand it. That means the machine language is meant for computers only. They are the ones the computers use, the machines are the ones that use them. Then it is not user-friendly because it's not easy to learn, to write and correct. Now, up to now, some of you don't even know how to convert decimal numbers to binary numbers. That is how hard it is. Now, if it is that hard, meaning it is not user-friendly. Then the other low-level language we look at is the assembly language, which is a second generation language. Now here, it makes it easier for even users like us, like you, to now talk to the computer. But we talk to the computer by making use of certain abbreviations which are known by the computer. For example, instead of saying multiply, you will say mult. This mult is a keyword. It is a word which the computer will have to interpret into binary codes so that it can perform. But we humans understand this. Now, mult, we use it when we're trying to multiply two figures. 2 mult 3. It means 2 times 3. So the computer has to convert this to binary code in order to perform it. So that's the assembly. We use abbreviations. We use words we can understand compared to what the zeros and ones. Then we have the third generation, which is a high-level language generation. These are examples of, these are the ones now which were created. Because when you look at the low-level languages, assembly and machine, those languages, they're hard for the human beings to understand. Yeah, they're very hard. So after the third generation now looks at how we can make it easy for us to communicate with the computer by introducing languages which are very easy, okay, to understand. Here we now use words, certain words, complete sentences, and so on. For here, examples of these third generation languages are the COBOL, the BASIC, Pascal, and Fortran. Okay, those are the third generation languages. Then we also have fourth generation languages, which were designed in the early 1970s. Now, here, they are very high-level non-procedural languages or rapid application development tools. Here now you have the examples of your Python, your C++, your C, your Java, your what, and so on. The ones you have been mentioning in the chat section, they fall under the fourth generation languages. They are the ones we are now using to create different applications, different systems, and so on, okay? They were designed in the early 1970s. For example, C was designed by a guy called Richard M. Ritchie, okay? Dennis M. Ritchie, sorry. His name was Dennis M. Ritchie. It was designed in the Bell Labs C, which is the mother language. We call it the mother programming language. Meaning, if you ever want to learn programming languages or programming, you should start by learning using C. Learn C. From C, you'll understand the rest of the languages because the way you write these other languages are the same, okay? So the mother programming language C was designed in the early 1970s by that guy called Dennis Okay. So now we use this for designing different programs we use right now. The web browsers, the blah, 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 the games we were playing, all of them were designed using the early 1970 languages, the 4th generation. Then we have the 5th generation. Now in the 5th generation, we look at what we call artificial intelligence. Now here we don't need to write. We simply talk. Here we use artificial intelligence. For example, when you're using your phone, you can use your phone, you can talk to it instead. Remember, you like saying, hey, Google, you like saying, hi, hey, Siri, before you say anything. You've been hearing those things in movies, even in songs. Someone says, hey, Siri, and then starts talking. Then the commands are followed. So that is it. 5th generation artificial intelligence. You talk, you no longer need to sit down and you tell the computer to do something by talking to it. As simple as that. So those are the classifications of programming languages. Now for today, we are going to stop there so that next week we meet, we shall look at language translators. I thank you all for attending these lessons. Now I'm going to give you the ability to actually ask me questions if you have any. So you put up your hand, I'll tell you to unmute and then you ask. I know you have questions. So if there are no questions, we can stop here. So you raise up your hand, use reactions, and then I will answer. Are there any questions? You can unmute. Yes, Tendo Isaiah, you have a question?
So I have a question. Like, I've been studying code
Yes,
math
please.
now, but how do you begin like giving the computer instructions?
That is why I told you to start with the, see, actually now before you start programming, you must make sure that you have the passion and clearly you have the passion, not so. Clearly you have the passion, and then making the computer understand, I told you we make use of what we call editors, IDEs, integrated development environments, okay? Now it is these IDEs that help us, we make use of what we call compilers, assemblers. Actually, that's what we are going to look at in the next lesson here.
Yes.
It is the
Yes.
compilers that now translate your program into what the computer can do, okay? It is in our next lesson that you'll understand your question even more, okay? But to make the computer do what you have programmed, it has to be compiled, it has to be interpreted, it has to be assembled, and so on, okay? Depending on which language you are using. I hope I've answered you, Tendo. Josh, yes, you have a question?
Sir, so concerning low-level language computers,
Yes,
yes?
please, like
Let's say in factories where
yes.
computers are ones doing most of the work. So in cases where someone, let's say, enters a command into the main computer, and then the communication between the main computer and the other computer is doing the work, do they use low language?
Yes, please. Yes, they use the low level. Now, the low level, by the way, the low level still exists. Even right now, it is still there. Because when you look at the translators later on, the translators are simply translating the programs we are writing to it, either by talking or by typing. They translate it back to the low level languages. Because remember, I told you, the low level languages are the ones the computers understand, zeros and ones. So if someone sends a command from a computer to a robot in the factory, the robot is going to understand it in terms of zeros and ones. Actually, this computer and the robot will communicate using the zeros and ones. For us, we don't know. We don't know. So for them, they're using still the low-level machine language. The only difference is when we use the high-level languages, they are translated using these translators to the machine languages they can understand. I hope I've answered you, Josh.
Yes.
Okay. Roman, you have a question?
Teacher.
Yes, please.
So you know how there are programming languages like Java. So let's say I lived in France. Would I program, is the Java universal for all languages? Does everyone program it the same way, or are there variations depending on your country and language?
Okay. That's a very good question, Roman. When I'm programming, I have to make myself comfortable. You understand? I have to make myself comfortable when I'm going to program. That means I have to make use of the language. Now, the language I'm going to use for writing on this editor will actually depend on the language I speak. There are editors which come, because when you are installing these editors, by the way, they allow you to even choose the language you are installing it in. If you speak Spanish, you'll be provided with the ability to install it in Spanish. That means all the menu, the words you're going to write are going to be in Spanish. That gives the computer an extra work to do what? To convert Spanish to English, or to convert the Spanish to what? To the zeros and ones it can understand. So the way you also write your program, Roman, is different from the way any other person can write a program. That is why when you come up with your own program, if you sit down and you come up with your program, the way you write your things, even the way you arrange your code, is going to be extremely different. That is what we call signatures, okay? Your signature of writing code is different from the signature someone else uses. If I give you my code right now, even if you understand the Java, if I give you Java, my Java program, you will go through my code and you fail to even understand it. Because first of all, I might not even write comments. Without comments, it's very hard for someone to understand a program. So it depends on what you want, okay? The way you write it is different from the way you write. So when you write it here in Uganda, someone, even your brother cannot understand it unless you wrote it together. Then the language in which you write depends on the language in which you installed the editor. Okay, Roman, is it clear?
Yes, sir.
Okay. Are there more questions before we conclude? Are there more questions? All right. Now, since there are no more questions, I thank all of you for